Hi learner. So today's recording we will talk about Spark and its ecosystem, and then we have a practical for that also. We'll learn today about how to design a cluster. Last video we talked about Hadoop and its ecosystem. We'll learn about many things about how Hadoop works, what are the limitations of Hadoop, what are the ecosystem of Hadoop, what are the different database we have, and also we'll learn about Hadoop ecosystem. So we have a pig, we have hive, we have HBase, we have a scoop, we have a flume, and what are the use case of this and what been frequently used in Hadoop ecosystem we talk about. So today if we talk about Spark, right, we have discussed about what is the limitation of Hadoop. It does not support real time. It's good for batch processing. Now today if we talk about Spark, right, it's not leading the big data, it's leading the fast data. The data which is galloping day by day. Number of clicks you are getting per second, 10 million clicks per second. Swiggy, Zomato, Ola, Uber, right? So this high bandwidth, right, where the velocity is very high. So in such case, does Hadoop fit match with your requirement? So that's the question, right? If not, then what's the solution for that? So yes, we have come with some solution that is called Apache Spark, and that's an in-memory process. So when we talk about in-memory process, right, it processes data in memory, it load data, input also we put into the memory, it processes data into the memory and put the output into the memory. It's very simple, right? A data which is on the disk, data which is in the memory, which is faster. Right, it's not about Hadoop and Spark, it's in your local machine, your laptop, right? For data is into the memory, right? What is faster? A data on disk, how you will process, how you will read the data. So of course the memory, that makes sense that data is much faster than what you have on disk. And that's the reason Spark comes with much faster result. And today's if we talk about Hadoop ecosystem being replaced from the Spark. In my slide you can see a brief about that. Spark and its ecosystem. Spark is written in Scala, and also you have an option to work with Python and Java as well. And the more important frequently what we are using, it's called PySpark. Okay, so you can see here these are the Hadoop ecosystem we have talked about, and this is what Spark and its ecosystem. Right, so slowly and gradually we see that what are the database, right, database is not being replaced, database still the data is onto Hadoop, but when we are putting the Spark on top of your Hadoop and we are processing the data which is stored on your HDFS or HBase. So here we have something, if you are using MapReduce program, then it's better use Java. Spark give you Java option to process data. If you're using Pig as a scripting, then we have Spark, we have option of Python and Scala. If you talk about Hive, right, Hive is mainly deal with the structured data. In Hadoop, if you are processing data in a structure, then Hive is called the SQL of Hadoop. If you ask me similar question, what is the best tool in Spark to deal with the structured data, that we have a Spark SQL which is 100 times faster than what we have Hive. Yeah, it's in memory, and this concept called RDD, resilient distributed data sets, which makes Spark much faster. Okay, we have some data ingestion tool like Scoop, it's for ETL, Flume for the streaming purpose online. Then we have a not ETL tool in Spark, but yeah, we have a streaming tool that is called Spark Streaming as well. Not as more what used frequently in Spark for the streaming, we are using Kafka. Okay, and in Hadoop, yes, you have Mahout. So being a data scientist, you have a Mahout to use the machine learning library on top of Hadoop. But if you ask me in Spark what is a machine learning ML library supporting, that is Spark ML. And in comparison to all this, you can see that it's taking a bigger picture. So yes, in comparison to Hadoop ecosystem, Spark tools are having a performance better. I'm not saying in all the case, yes, there's variation in the use case, but most of the use case we see that Spark is the first option to in terms of data processing, real-time batch processing, OLAP, OLTP, streaming, machine learning. We take the first priority with Spark. Now let's come to cluster. So here we have a Google Cloud Lab. So in this first thing we have to design a cluster. Right, as I told, we discussed about a cluster is nothing, it's a group of machine, high scalability, horizontal scalability we have talked about. Okay, so how to design a cluster and how to achieve the services like Hadoop and Spark, PySpark in your Google Cloud. So the service name is called Dataproc, right? So first of all, you have to go and search it, write it Dataproc. Okay, this is where we have a Dataproc. Just click onto the Dataproc. So here we have a option called create cluster. You have both options. You can click onto this. Then there are two options you have. You can create a big data cluster by Kubernetes engine as well compute engine. We will take the priority with compute engine. Now you see that there are multiple options you have. All right, set up cluster, set the configuration. If you are looking for some kind of cluster configuration in terms of networking, security, that option is also available. Let's go one by one. So you can give the cluster name. Let's say write it Prwatech. So okay, now you have a different data centers where you want to design this cluster. So you can select US data central. You have different options. So I'll go with the US data central. Now John will skip. Now the cluster type, we have three different options here. So if you want to design a single node cluster, means on a single machine your Hadoop, Spark and all daemons, all the ecosystems are running on a single machine. So if you want to go with that option, you can go with a single node. It's very lightweight, right? But you cannot get the better performance. If you have option, if you are looking for to design a cluster where master daemons running on a one machine and worker nodes are running on a different machine, so you can go with a standard. This is option where we have a one master node and a number of worker nodes. This is the production environment. This is very high configuration, high availability with 3 master and worker nodes. If you're using the free account one, this option's not available in your account. So either you can go for standard or you can go for the single node. I will go with the standard. So where I will make a one machine, master and 2 worker node. Okay, let's go with the version. So what software versions you have? Hadoop and Spark. So all the versions are available. You can see the Debian, Hadoop, BigData, Hadoop, Spark and Linux interface, Ubuntu, Red Hat, CentOS, Debian, all these options you have. So you can see here there are multiple options are available. Okay, Hadoop 3.x, 2.x, Spark 2.x, 3.x. There are certain limitation in terms of file format also. So depends upon your requirement. I will go with the latest one, Spark 3.3 and Spark 3.5 and Debian Linux interface 1.2. Okay, click, select. Hope it's clear till this part. It's very simple to design a cluster on Google Cloud in comparison to other cloud environment. And then now, yep, auto scalability, Spark performance enhancement, these all the options are good but optional. It will take your more credits also. So as of now, we'll focus on creating a cluster. This option you have component. If you want to get a UI, enable component gateway. If you want to get the UI also, UI interface. So you want to see the Hadoop name node, data node, UI interface. So you can enable the service. And there are some advanced tools, right? You can see Hoodies. These are some latest third-party, we can say, services if you are looking for that. Let's say if you are using the PySpark, of course, Jupyter Notebook is needed. You can select a Zookeeper also. One of the Zookeeper is the managed coordinator. Such services, as per your requirement, you can select in your cluster also. Now I will move to give you a machine name, select your region, select the if you are using for first time, then I will suggest you create a one node and two node of cluster. Okay, then you can go with single version. I will go with the latest one. Network configuration, let's be default. Component gateway, I made it enable. And now these are the services. If you are needed, you can add it. Now after this part, you can go to the configuration. What is the machine configuration? Right, like cluster is nothing, a group of machine. A machine is nothing, it's you have to define the configuration, RAM, CPU, disk, operating system, right, many other configuration like we have already done in the compute engine when we are creating the instance. So here we have a manager node, right? What we have selected machine number, one master node and worker node. So what the machine configuration you want to give that machine, okay, in the cluster. So here you can define. So you have a multiple option, a general purpose, compute optimized, memory optimized, GPU, right? So we are here go for general configuration, and we'll set all the configuration here. Here we have a multiple series, right? N1, N2, first generation, second generation. I will select the minimal configuration. It is always recommended to use it wisely, all your credits. So I will go with the minimal configuration, which were N1 series and first generation. And this is N1 standard. You have a 2 CPU, 1 core, 7.5 GB memory. And here we have 50 GB of, I will make it 50 GB, that is sufficient. Okay, 50 GB of the disk, that is sufficient. And then you have machine type, SSD, balance, you have all the options here. So this is the master configuration. Okay, machine master node I have configured, and then I will go with the worker node. Now checking on the worker node, you can see here series N2, right? I will go again, make it similar for N2. Okay, so here you have N1 2 CPU, you have 7.5 GB. Now you have to decide in worker node how many machine you want. So I want to go with, you see that the default is 2, you can make it 20, you can make it 30, depends. Okay, but of course you have a limited credit, so as I mentioned that use it wisely. I will go with the 2 worker node, and the default should be also minimum 2 worker node should be here. Again, the disk size I will put it 50, and what all as default, put it the same, and yarn cores, yarn memory, right, all you have. So this is all about the configuration. In initial stage, there are many other options. We have networking related firewall, so we can skip as of now. Customize, so internal IP only, we just, okay, mark this, and manage security. If you want to do some security concern about your cluster, you have this option, can assess, right, all the options are there. I'm not going to do, just brief about security related Kerberos, right, are the options you have to design this. So I'm just skipping all. I'll just create the cluster. It will take time, although we are creating a 3 node of cluster. So of course it will take time, and while creating the cluster it is showing the loading content. It will take an average 3 to 5 minutes, so we'll wait for that. Alright, so you can see now when it is your cluster is ready, it will show you the running. Sometimes because of some configuration or the location, there's some issue, so your cluster may be not created, and it will pop up, or it will show you somewhere the orange color, right, means, and it will show you some what is the issue. So in that case you have to check the configuration. That may be the one of the reason. There may be multiple reason. Okay, but now as of now we have a cluster which is 2 node of cluster, and it is running status, it is stable, and the location you can see US data central, zone is US. Total number of worker node we have a 2. Flexi VM, we have not put any flexi VM, schedule deletion, and as I told you, right, this is what the bucket. So ultimately you see here the bucket, right, means why this bucket created. We have not seen any option to create a bucket there, right, but this is the bucket. It has been created because what are the data you're putting in your database on your HDFS, HBase, or what are the metadata information, cluster information being there, it will be available on your bucket, on your cloud storage. So let me open and show it to you, right. You have a configuration, the bucket names you see here. You can, if you want to customize, this is possible to make the changes also. So Google Cloud, Dataproc, Meta Info. This is a bucket path. You can need it, you can copy it from there itself. Now the cluster is ready. Now what I will do, I will start the machine. I'll click onto the your bucket name. So you can see here you have a monitoring. So you have a monitoring tool for every services. Anything is going on, if something got fail and you want to come and monitor your server, your cluster, you can do it from there itself. This is the jobs, like if you are running jobs, right, you can run job parallelly. That option, of course, you have parallel jobs options are there, and if you want to know the status of the job, the progress, right, you can come and check it from there. Now we have a VM instance, right? We have 3 instances, right, that we have created, and you can see on my screen. One is a master node, Prwatech M. One is a Prwatech W0, that is a worker node, and Prwatech 01 is a second worker node. And one standard, all the machine type is written there. Usually you operate your cluster from the master node. You can see here SSH option. Alright, this SSH option is available on your worker node also. You can go and operate from there itself, but the best practice, it's recommended to operate your cluster from master node. So I will click onto this. Alright, perfect. So your machine is ready, and you have to write it very simple, right? Sudo JPS Java process server to check the daemons. Which daemons? Master daemons, because just now I've opened what? Master nodes, and I'll click onto this, and you can see here all the master daemons are running here. You have a name node, you have at your secondary name node, you have a H master. There are multiple master nodes of Hadoop components and Hadoop ecosystems as well. Okay, now if you ask me worker node, so of course I have to go and run it from the worker node. SSH is there. So I will write the same command, sudo jps, and you see that data node, your node manager, measurement. These are the worker nodes which you have, and of course on the other we have a 2 worker node, right? You can go the same way. You can open your SSH, and on that machine, what are the worker node which are the worker node is running, you can run the same command, sudo jps, and it will work. Okay, and now this is more about your Spark. This is all about your Hadoop, right? And if you want to see what all the softwares where it is there, so you can write cd user lib, and you see that you run this ls, sorry. Okay, you can see your Hadoop, Spark, Python are all the softwares are available into this directory. Okay, and if you want to see the Hadoop database, right, so you have to write a simple command, Hadoop fs-ls, and that's a root directory. I want to check it. Let me clear it. Okay, let me clear it, and you have all the commands available. Up arrow key, the history, you can see it here. And if you want to see what all inside user, right, so this is the directory, and if you want to see, this is your HDFS directory where when you will store the data on HDFS. Okay, and there it will come and show. So there are different different directory where you want to store the data in a Hive, in a HDFS, in a HBase, right? Spark, Yarn, all we have. So as per your requirement, you can select. These all are the directories already created. If you want to create your own directory, that is also possible, and that's very important. You should have a fair understanding of Linux command. At least basic understanding is needed for that. Okay, so this is all about your Hadoop, and let's come to the second part. So if you want to run Spark, so if you want to run the Spark with the Scala, so this is the command, spark-shell, and it will take time. So this is the command. If you want to use a Spark with Scala, you have to write simply spark-shell, and you can see on your screen your Spark cluster is ready, and you can operate your Spark with Scala, and all the versions, everything will be written there. It will take some time, right? Now you can see here you have a Spark, a Yarn coming, Spark 3.5, and here you have a Scala is there. Okay, it's quite similar to your Python. Okay, now I will just come out from this. Okay, and if you want to run the Python with Spark, you have to write PySpark. Okay, PySpark, yeah, it's working, and here you have a PySpark, Spark version and the Python version, it will reflect on your screen, right? So Spark version is 3.5. Spark, you see here, that is running your Spark on top of Yarn. Yarn is nothing, it's a component of your Hadoop 3.x and 2.x. So you're running the Spark on top of Yarn, top of Hadoop. So it is showing, if to cross check, yeah, you see that it is showing here. So that sense that yes, your Spark is running on top of your Hadoop on Yarn, and this is your ID, your Spark context, and this is your Python version. Right now, you can run the basic command of Python. Is equal to 1, b is equal to 2, and a plus b. A simpler command of Python, and although we have a rich library, we have a different type of library in PySpark, okay, but knowledge of Spark with Python is mandatory to use it. Okay, hope you understand how to design a cluster. Okay, we'll discuss more about Spark, Python, and some commands and Hadoop commands, how to store the data in a file in the next video. Hope you learn well. Thank you. Hey, don't forget to download our app for access to free courses and interactive quizzes. Stay connected with us on social media for updates and free content. See you next time. Happy learning.